Carrington-class CME narrowly misses Earth, presented by Science at NASA. In mid-April, scientists, government officials, emergency planners, and others converged on Boulder, Colorado for NOAA's Space Weather Workshop, an annual gathering to discuss the perils and probabilities of solar storms. The current solar cycle is weaker than usual, so you might expect a correspondingly low-key meeting. On the contrary, the halls and meeting rooms were abuzz with excitement about an intense solar storm that narrowly missed Earth. The close shave happened almost 2 years ago. On July 23, 2012, a plasma cloud, or CME, rocketed away from the Sun as fast as 3,000 kilometers per second, more than 4 times faster than a typical eruption. The storm tore through Earth orbit, but fortunately, Earth wasn't there. It did, however, hit the Stereo A spacecraft. Researchers have been analyzing the data ever since, and they have concluded that the storm was one of the strongest in recorded history. If it had hit Earth, we would still be picking up the pieces, says Daniel Baker of the University of Colorado, who presented a talk entitled The Major Solar Eruptive Event in July 2012, Defining Extreme Space Weather Scenarios. This storm might have been stronger than the Carrington event itself. The Carrington event of September 1859 was a series of powerful CMEs that hit Earth head-on, sparking northern lights as far south as Tahiti. Intense geomagnetic storms caused global telegraph lines to spark, setting fire to some telegraph offices and disabling the Victorian Internet. A similar storm today could have a catastrophic effect on modern power grids and telecommunication networks. According to a study by the National Academy of Sciences, the total economic impact could exceed $2 trillion, or 20 times greater than the costs of a hurricane like Katrina. Multi-ton transformers fried by such a storm could take years to repair and impact national security. A recent paper in Nature Communications, authored by UC Berkeley space physicist Janet G. Luhman and former postdoc Ying-D Liu, describes what gave the July 2012 storm Carrington-like potency. For one thing, the CME was actually 2 CMEs, separated by only 10 to 15 minutes. This double storm cloud traveled through a region of space that had been cleared out by another CME only 4 days earlier. As a result, the CMEs were not decelerated as much as usual by their transit through the interplanetary medium. Had the eruption occurred just 1 week earlier, the blast site would have been facing Earth rather than off to the side, so it was a relatively narrow escape. When the Carrington event enveloped Earth in the 19th century, technologies of the day were hardly sensitive to electromagnetic disturbances. Modern society, on the other hand, is deeply dependent on sun-sensitive technologies such as GPS, satellite communications, and the Internet. The effect of such a storm on our modern technologies would be tremendous, says Luhman. During informal discussions at the workshop, Nat Gopalswamy of the Goddard Space Flight Center noted that without NASA's stereo probes, we might never have known the severity of the 2012 superstorm. This shows the value of having space weather buoys located all around the Sun. It also highlights the potency of the Sun even during so-called quiet times. Many observers have noted that the current solar cycle is weak, perhaps the weakest in 100 years. Clearly, even a weak solar cycle can produce a very strong storm. Says Baker, we need to be prepared. For more information about storms, on Earth and among the stars, stay tuned to science.nasa.gov.